So this video is about the shapes of polyatomic ions, which relates back to the Lewis diagrams for these ions. So the first example we're going to have a look at is BH4 negative. Now if I change how I write that to being BH4 negative, hopefully that will give you more of an idea of what I'm doing as I go through this. So the first thing we're going to do is pop boron in the middle and then surround it by our hydrogens, and we've got 4 of those. Each of those hydrogens is easy to deal with. They've only got 1 electron. Boron is in group 3 of the periodic table, so has 3 valence electrons. And then we're left with 1 extra negative to head into this from this here, and that will finish that pair of electrons. So what we've got in this ion is 4 bonding pairs of electrons, and when you have 4 bonding pairs and no lone pairs, you end up with our familiar tetrahedral structure that's very similar to methane. The second one I'm going to have a look at is Br F4 negative. So again, this is really strange, this one, because this looks like, what is going on? We've got a halogen bonding with 4 other halogens, and it makes no sense. So all we have to do is just follow the electrons. So we've got our central atom, which is a bromine. We've got the fluorines, and we'll just spread them round about and see what happens. Our fluorines are round about. If we pop on the 7 electrons for those fluorines, like that. Then if we add in bromine's electrons, it's got 7, it's a halogen, and we can account for 1 here, that's 2, that's 3, and that's 4. So the 4 are used to complete those covalent bonds, but we've still got 3 more electrons to go in from the bromine. And we've also got this 1 electron here. Now we know, although this looks really odd, but electrons pair up. So what we're going to do is we're going to pair these 2 up to turn it into a lone pair, and we'll also pair those ones up to turn those into a lone pair. So now we have 4 bonding pairs and 2 lone pairs and that would form this kind of structure here, where we've got 4 bonding pairs and the 2 lone pairs, the ones that aren't connected, would go top and bottom. So the orbitals are in an octahedral structure. Hopefully we can see that. The orbitals are octahedral, but the actual atoms, if you ignore that, the atoms themselves are all in a plane, and we've got a square in a plane, so the shape of that would be square planar. And how we would normally draw that would be the bromine, and would show two bonds coming out towards us with our fluorines, and two bonds away from us, and that's us done. The last one I'm going to have a look at is the S, F5 negative ion. Hopefully you can see that pink. Okay, so we'll pop our sulphur in the middle, as we've been doing, our central atom in the middle, and 5 fluorines just spread round about. Any old place, it doesn't matter. The fluorines have all got 7. So that's 7 electrons for each of the fluorines. Now if we put in sulphur's 6 valence electrons, we're going to have one here, that's 2, number 3, number 4, number 5, and then we've got one that can't go into one of these bonds because these bonds now have both electrons, so they're complete. And the last electron we need to deal with is our negative charge from here, which will pair up It's not for writing, but hopefully you can see that. So that will pair up with that sulphur. So what we've now got with our sulphur is 5 bonding pairs, and 1 lone pair of electrons, which means that we've got 6 bonds round about our central sulphur. So that would be shown as, or at least we've got 6 pairs of electrons round about our sulphur. So that would be shown as this shape here, with our fluorines all round about. And our problem is that we don't have a fluorine to go here, so that instead of a bond is a lone pair of electrons. So the shape that that would be in 3D is like this arrangement here. So we're back to our octahedral structure for the electron pairs, but there is no bond coming out the bottom here because this is our lone pair. So although the electron arrangements are in an octahedral structure, this bond doesn't exist. So we have this structure here. The bottom 4 fluorines are planar to each other, and then we've got one up the top. So, take 2. When trying to come up with a name for this structure here, it's worthwhile comparing that to one that we've met previously, which would be this. So if we've got this triangular base pyramid, that one was trigonal pyramidal. But in chemistry, instead of the prefix tri, when we have 4 things to consider, we would go for tetra, which leads us to tetragonal pyramidal. So although the structure of the electron pairs was octahedral, the actual shape of the molecule is tetragonal pyramidal.